Physical Science. This is Mr. B. We're going to finish up Section 1 of Chapter 2 today, Classifying Matter. If you remember from our last video, we left off talking about pure substances and how they had the same uniform composition all the way through. We had two examples. We have something that's called an element, which is our most basic, and then we have a compound, which can be broken down further. However, it is still uniform throughout. It has the same composition of different elements throughout the entire sample of the substance. So now what we're going to talk about is something called a mixture. So mixture is going to be the focus here to start. And again, it always kind of starts us off with an example. So it starts off the example talking about salsa, and we have a recipe that can help you guide you make salsa, and you can use exactly the amounts in the recipe, or you can adjust the ingredients on your own taste. Salsa is a mixture. Each batch may be slightly different. So unless you're the most skilled chef in the entire world, and you can cut out tomatoes and peppers and onions at the exact same size and make sure that they're exactly uniform in every single bite, then salsa is always going to be considered a mixture. And what a mixture is, based off of its properties, it can vary because a mixture is not fixed. Again, the composition is very different. So I'd make sure I definitely wrote this part down here, that the properties of a mixture can vary because the composition is not fixed. They can retain some of the properties of their individual substances. So again, salsa obviously has a red color because it retained that property from the tomato. And the properties of a mixture are less constant than the properties of a substance. And again, if you take a bite of table salt, you're going to get the exact same taste every single time. That is a pure substance. It is the composition is very constant. It's very fixed. However, if you take a bite of salsa, one bite might have more tomato, next bite might have more pepper, next bite might have more onion. So the properties in a mixture, they're much less constant than the properties that are found within a substance. And within our mixtures, again, we can break them down into more categories. It is basically based off of, when we classify them, how well the parts of the mixture are distributed throughout the mixture. So our first type that we have, hopefully we've maybe heard this term before, is a heterogeneous mixture. So I'd make sure I have this down, and that is when the parts of the mixture are noticeably different from one another. So salsa is a pretty good example of a heterogeneous mixture. Again, we can easily see all the different components of that. It's pretty clear what is inside of there. And then our other example is a homogeneous mixture, and the substances are so evenly distributed that it is difficult to distinguish one substance in the mixture from another. So that is something that almost be a little more pure in form, again, that we can't necessarily see all of the differences that are present. Again, it'll be a substance that has multiple different things inside of it, but they're so evenly distributed that we cannot tell. And we'll get a couple more examples here in our next one. So the first one, we have sand is a heterogeneous mixture. Again, if we look at this picture right here, we can easily see that there are different components that make up this sand. However, the spoon, which is made up of stainless steel, is a homogeneous mixture of iron, chromium, and nickel. Now, I can tell you that just about no one can walk or look at this spoon right there and say, oh, yep, there's a piece of iron, there's a piece of nickel right there, and there's a piece of chromium right there. No, that's not how it works. We look at it, we just see a nice, smooth, shiny, silvery type appearance, and that is why we call that a homogeneous mixture. Again, these three things, iron, chromium, and nickel, are all inside this spoon over here, but and they're so well mixed in that we cannot tell the difference. So those are two types of mixtures. We have hetero, where again we can see the different types, and we have homogeneous, where they're all so uniform we can't really tell the difference. And so to wrap this up, we're going to talk about, again, some more things that kind of go along the line of mixtures as well. Actually, yeah, so I'm sorry, these are mixtures. So we have something that is called a solution, a suspension, and a colloid. So those are three new vocabulary words. I'd be on the lookout here to make sure you have jotted down. So the main difference among these is actually the size of the particles in the mixture, and it has an effect on the properties of the mixture. So based on the size of its largest particle, a mixture can be classified as a solution, a suspension, or colloid. So I would actually mainly focus on this part right here. So this is how we tell the difference between these three things right here. So we can tell a solution from a suspension and from a colloid based on the size of its largest particles. So we will get, again, this stuff makes more sense when we actually have examples to look at. So our first one we have is a solution. So when substances dissolve and form a homogeneous mixture, the mixture that forms is called the solution. So I think that probably the easiest example would be if you're making powdered lemonade, you drop the lemonade into the water, you stir it together, the powdered lemonade dissolves, and we have now what is called a solution. So that is I would say, one easy example of a solution. And a suspension is a heterogeneous mixture that separates into layers over time. So my easy example for this one is I always think of Italian dressing. If you see it in the clear bottle, there's always different little, the oil separates from all the different flavoring. You always have to shake it up before you use it. Again, because if you don't, you might just get one big nasty bite of oil or some big burst of just Italian seasoning that might not taste the best on its own. So that is probably my good simple example of a suspension. Something if you leave it long enough, it separates into layers. And again, a solution is when the substances dissolve. So I think of, again, pouring powdered lemonade into water for my solution example. And what a colloid is, so this is the one I think is a little more confusing. A colloid contains some particles that are intermediate in size between the small particles in a solution and the larger particles in a suspension. So this one, a colloid, is something that kind of falls in between a solution and a suspension. Solution completely dissolves, suspension will not dissolve and they separate. Colloid kind of forms somewhere in the middle because, like solutions, they do not separate. So I would maybe write this down for a colloid, that within a colloid they will not separate into layers, and you cannot use a filter to separate the parts of a colloid. So they are really similar to a solution. It just has to, the main difference between them is that the particles that you find in a colloid are much bigger than the particles that you're going to find inside of a solution. So this one we'll go over more in detail in class because it does get a little confusing, but that's kind of the best way I would remember it, is that a solution has just, again, really small, everything's dissolved. A colloid has particles that are a little bit bigger. They don't quite dissolve all the way, but they're not going to separate out like a suspension does. And to wrap it up, we'll get some examples. And again, we'll go over more examples in class for that one. So these liquids that we're going to look at right here represent the different categories of a mixture. So windshield wiper fluid is a solution. Again, everything inside here is completely dissolved, and again, it's not going to separate. Muddy water collected from the swamp is a suspension. So right here, again, over time, if we let this water sit, all the big muddy particles are going to sink down to the bottom. The water is going to be at the top because it's less dense. And then milk is a colloid. So milk has some bigger particles in there. Again, the particles are never going to separate out like they will in the muddy water. However, if we analyze the milk, we're going to see bigger particles inside the milk that are found inside the windshield wiper fluid. And again, that's kind of the main difference between those. So that is it for section 1. Let me know if you have any questions.